Your favorite.
Okay.
Okay.
Gotcha. Okay. So, okay, I'm online. Perfect. I need to minimize my screen a little bit. So look, it's I'll be honest with you, it's quite good to have two screens because we're linking one software with another. If you've got two screens, but you need a good graphic card. Most graphic cards got like a few plugs in the back to have more screens. So I use two screens. So, but for tonight, we'll just cram them in all on one screen. So let's move that across like that. Wolf, can you see both screens or not?
Yeah, I was just checking out your desktop. It's a little bit tidier today.
You're being sarcastic. All right, okay. So we've got 3D Slicer on the left and we've got Blender on the right. So these two programs talk to each other. So we've got a DICOM on the left and we've got models on the right-hand side. Now we have to bring them in, forward and back depending on what we are doing. So we know that we need implants, we need to align the models to the DICOM, and to do that we need a segmentation model. And this is where it all starts. And this segmentation model is a printable STL file, by the way. So let's go into 3D Slicer first and start. So in 3D Slicer, we've got two add-ons. One is if you look here, you've got dentistry, you've got the Slicer Blender link. There's basically only one button that you need to know. It's just connect. And the other one is a Slicer Pano. There's quite a bit going on over there. Anyway, so let us make a model. So the first thing up top there's like a pen there. We're going to click that. That's a segmentation editor. Now we're going to click on add segment. So this usually comes up, it's green. I'm going to call that, I'll just call that skull or whatever, skull, just so that you know what you're doing. And then what we're going to do is we're going to go here, there's a threshold. If you look here, threshold. Some of our users have downloaded the later version of 3D Slicer. Our videos don't cater for the later version, so you're going to have to figure that out yourself, but it's very similar anyway. But the icons are just arranged a little bit differently. So here we're going to click on the threshold, and then as we move the slider, we can see this green. So it's a compromise between too much noise, which you see there, you can't even see the model properly as I zoom in, and too little. If it's too little, we won't get much of a model. So here what I'm going to do is I'll set that to around about 940. So, but that does differ with each one. Actually, that's not quite enough. So we'll just take that a bit more, maybe like that. I will zoom in as well by just scrolling with the mouse, just to see that I haven't taken, there's a lot of noise in here and a lot of scatter as well. So not such an easy case. So maybe something to that effect. Okay. Yeah, that looks okay. Then what we're going to do is we're going to accept that, apply. And what that does, it makes a model. When we click on show 3D, it generates the segment over here, like over here. And you'll see we've got a cube here and the skull is like off center. So to get it into this cube, you're actually not moving it itself. It still stays in the same CT location. You can just click on this and that puts it into this cube, which is easier to work with. Then we're going to take the scissors. There's a scissors icon. And in the scissors, we can get to choose what we want to cut. So I'm going to click erase outside and I will then outline the area that I want to cut. So that would be that, okay? And then I can further cut it if I want to. So again, scissors, and I'll just erase everything else, okay, like that. Perfect. Now the next thing we need is we need to allocate the nerve. So we've got the canal running across like that. But in order to do that, we need to use a slicer panel because we need to see these slices. So, okay, again, we go to the dentistry, look for slicer panel. We're going to select the segment which we're working on, click select, and then we've got an input curve over here. And at the moment, we don't have a curve. Now we need to draw a curve, and that's quite easy. There's like a little red dot over here. Click on that sign and then open. You'll see open curve. Don't select close curve. Click on the open curve and then plot your curve. So I left click all the way like this. We don't have to go all the way across the arch. I'm going to right click to get out of that. And then what we're going to do is we're going to select the curve, input curve. By default, that's a C. You can draw as many curves as you like, by the way, and it'll follow. The slices will follow the curves depending on which curve you select. So we're going to select that. And as soon as we move this one here, all the three slices move with it. Now you don't see the three slices itself yet, but as soon as we move the tangential and the actual, then we've got all of the slices. But for this Zoom session, I personally only like working with one slice because it gets a bit confusing sometimes. So I'll just show you how to do it if we work with one slice. So in 3D Slicer, to hide your slices, you've got like a little link button here and a little eye. So as soon as you close the eye, all of the slices disappear. So if you wanted to open one slice, unlink it, because this links all the slices, and open up the eye. That means that we've only got one slice that we need to worry about. For me, it's easier, but for you guys, I don't know, it depends on, how you work. Now I'm going to take this one, and of course it moves with the curve. I'm going to take this. Well, okay, let's take this like this, and we're going to move this to the nerve canal. So here, move it along, like maybe halfway in between those teeth, and then I'm going to twist and turn it like this, yeah? And then, on the right-hand side, I can already see the nerve canal. So that takes a bit of practice, I'll be honest. When I first started, it was an impossible mission to find it. But, with a bit of practice and knowing how to rotate these, it's actually quite easy to do. Now, in order to draw a curve, like a tube, we're going to draw a tube. We're going to go back to the segment editor, this little pen over here, and we're going to add another one. Don't start drawing on this one because you're going to lose your hard work in making this model. So click on add, and then we're just going to type here nerve, that we know what we are creating. Of course, then what we're going to do is we're going to, here there's a little icon that says draw tube. Left click on that, and it says radius. So here what I'm going to do is I'm going to put 1.5 because I find 1.5 is suitable. 1 is a little bit thin, I find, but you can even put 2 if you wanted to. Now then click on this icon. So exactly like we did before, and we drag the points, we're going to left click on this one. And then what we're going to do is we're going to left click. And then with the mouse, I'm moving the mouse, and then I'm going to follow this canal going upwards like that. So I'm trying to be as precise as what I can. We don't have to take it all the way up because our implant site is over here. So, but it's very visible if you've got the slice correctly aligned. Then what we need to do is we're going to apply that, which will then solidify it and make a model. Now you can change the colors, but there's no need to do that at this stage. So now these two models we need in Blender. So once you understand how this works, you like halfway there in the digital planning. Okay, so we're going to go export files. This is important because you need to make sure this is on RAS. Now, hospital CTs work with the other one, the LPS. The dental scanners work with the RAS. Now, everything else is unchecked. Scale is 1:1. Move it to where you can find your file and then export it. Now, this is part one of what we are trying to do. Okay, so I'm going to go now into Blender, and then we're going to go and do the Blender stuff at the moment. There's no link that's been established between the two yet. So I'm going to go File, Import, STL. I'm going to look for this now. So desktop, I think it's here, nerve and skull. And we're going to import that. Now, for some funny reason, this CT is like quite far away from the center of Blender, but we can't move it. It needs to be standard, so please don't move it. If you're concerned, in the model designer, click the lock this button over here. That'll lock it, so we can't move it. We need to move this to there. But because we've got two models, what I'm going to do is I'm going to join these two. So if you know the shortcut, it's Control-J. If you don't know the shortcut, learn the shortcut.
Or you can right-click as well, Michael.
Oh, yeah, or you can right-click. Yeah, that's a good point, Wolfgang. I don't usually use it, but that's a good point. Or you can find a button where it says join. Okay. Now we're going to move this to that. And basically what I want to do is I want to just grab this, G to grab, R to rotate. And I'm doing this because I want to be able to see where I'm going to put my points for alignment. Otherwise, if it's on the other side of the screen, it's quite hard to remember where you're going to place these points. So we're going to go to the alignment add-on here, the ICP alignment add-on. This becomes a moving and that becomes a target. Okay.
Destination.
So the destination. Yeah, correct. Now it automatically flicks back onto the moving so that we know we need to place our points. So here you need to be careful. And when you're placing these points, you have to think about the X, Y, and Z. So the X, so you need some type of a stoppage on all three axes. If you don't, if you only put point there, point there, point there, point there, you've only covered this axis, which means that this can flip upside down, okay? So this is why we don't want to confuse the system. We need to think about how we're going to be positioning our points. All right, so I'm going to click place landmarks, and I'm going to have a good look and see where I could place. So this could be an area over there. So I'm going to put one there. And then the bottom of the canine, perhaps we can put one over here. So that's that covered. To get the Z axis, so we can put one up top here. So here by the cervical area over there, and then maybe we can add another one. While we don't have the molar over there, we could possibly put one over here. Okay, there. Okay. So this is why I've brought the models close so that we can see where we've put these points. Click on enter. Then we're going to select this one and do the same thing. Place landmarks. So one there, up top, and one over there. Enter. Select both and perform initial ICP and then perform alignment. And this is where you see how it aligns. Now, you have to double check, and it doesn't look, yeah, it could be correct because my ICP model, if I look at it, yeah, no, I'm not 100% happy with this tracking. So this is the most important thing, because if your tracking isn't correct, then your implant guide is not going to be correct. And that's just going to cause major problems. So we don't want to end up with having problems. So for some reason, I haven't gotten a good alignment. I'll just place it a little bit like this, or I can just take it like this again. And we're going to do the paint method. So let's engage in that one. So paint, so name moving and name destination, color moving. And we're going to, with the C key, we're going to color a few over here like this. Okay, so it's actually good that this happened when I first practiced this afternoon. I didn't have a problem with it, but that's good because then I can show you both methods. So here we're going to take this. In fact, we could select most of this over here like that. Something like that. Yeah, that's good. And maybe the inside as well, a little bit like that. Okay, so we're going to apply that, and then that will then cut out the mesh of it so we can see what's going on. So here I'm going to do the same thing. So we've got here a little bit like that. Yeah, over here like that. Yeah, and a bit on the inside. Okay, apply. Now we get to move one to the other. Okay, so the best way to do that is from the top and then from the side, like that. And these segmentation models can sometimes be a little bit difficult. So, yeah. I think that should work, Wolf. What do you think?
That's all right.
Okay, so select both, perform ICP.
Yeah.
Okay. Okay, and confirm. Yeah, that's looking way better, but we will confirm that in the actual. Can you see here? This is probably from my segmentation model not having the threshold enough. So that's another thing. Now, what we're going to do is we're going to put this into 3D Slicer. Okay, so the way we do that, before I do that, I want to open up the Blender Slicer link. So we're going to go into the guide module and click Server. And over here, we're going to go into Dentistry and link Blender and connect. So now the two of them are talking with each other. But before I'm going to move this, I will just give this a bit of a transparent color. And this is quite important because then we get to see, we can get to see through this a little bit. So I'll just put 0.8, and then we're going to click on one off transfer. So we'll just wait for it to transfer. Okay, so it's transferred over here. Okay, and we need to now check that this alignment is correct. So if we look at this, we've got quite a good alignment, even though in Blender we didn't think, but that was probably due to the threshold. So if I look here as well, yeah, we've got a good alignment. So now I can be rest assured that I can do the implant planning based on this alignment. Okay, are there any questions so far? Wolfgang, have you got any questions that you can think of?
No, I've got no questions going through. Feel free to type away, and now and then I'll just glance at the message window.
Yeah, there's one thing some of our users have tried to then take this model and transferred it over to 3D Slicer. Now, this won't work because it has so many vertices, and this is going to clog up the system. So when I click one of transfer, we reserve that to easy things like with low vertice count. And the reason why we export it out of 3D Slicer as well is because of the vertice count of these segmentation models. All right, we need a few teeth. And also what I want to do is we don't really need this top model. Okay, so we can discard that as well, because there's no real point to having this top model. Or if you want to keep it, that's
Or you
also
can
okay.
also export it, and then if ever you want to bring it in, import it again at those coordinates.
Okay, so we need to have two or three teeth. Okay, so we're looking at these over here.
So, Michael, you've just gone into
Choose
the wax up, into the guide module to do that.
Yeah, to import the teeth. Okay, so delete unwanted. So this is very similar to the wax up module. And so again, I look at it from the top view. I find that the easiest way in 3D, because it gets very confusing sometimes to get something into the correct position. Okay, so we can just take that and grab that and put it into, I may just get rid of the top model, I think. Also, we are finished with the this ICP model, although we could use it for demonstration of our implants, Wolfgang, when we put the implants in.
Maybe put it in another collection.
Yeah, I think so. So if sometimes if you can't click on something, that there is a purpose behind that. Like I'm trying to click on this model and it's not working, and that's because it shields the transfer of the models. So okay, we will just unlink that, separate, and I'm going to take this and move it into a hidden collection. Hidden, like that, and we're going to close this off, and then this one for now I can put into another collection. I'll call that ICP, and we're going to hide this one as well. Okay, now we've got these teeth. I'm going to scale them down a bit. Now, if that happens, if you use the S key and it scales like that, it's scaling with its with the median point. So with the, hold on a sec, with the median point, set it to active element, and then it will scale like that. So if you've noticed earlier what it did, and that's because it was set to median point. Okay, like that. So that's looking good. Like that. Perfect. I'm going to scale them a little bit like longer, like that. And then we're going to just join them. And I'm going to also give them a bit of a color.
Yeah, I was just going to say, because you set the model quite transparent, it's a bit difficult to see.
At the moment.
Yeah.
Yeah. Well, maybe I'll just give it a little bit. Yeah. Okay. So this one now I'm going to transfer as well. Okay. So that we can get to see it in 3D Slicer, which we can now. Okay. Yeah. Okay. So I've lost the model in this process. I'll just click on the model and transfer it again. Okay. Now we're going to bring in our implants. And I'm going to just quickly, if you want to hide something, just click on the eye icon, then you can hide it. Now for this specific case, I've chosen a few Medentica implants. So we're going to go to the components module. And we're going to load the library, Medentika implants, and I'm going to choose the microcone, and the number is 20. So these are 2038, 2041, 2040, 2138. Here we go. I think they are 9 millimeters by 4 millimeters or something like that. So the first thing we want to do is we need to accept this one as our implant that we are working with. So click on accept your implant, and this creates the necessary assemblies that we need. And then what we're going to do is we're going to copy this implant. Now, if you need different implants, just bring in your own implants if you want to. So here, duplicated selected implant. Now I've got 2 of these implants, and we're going to provisionally place these into where we want them to go. So here's the first one. Okay, like that. And I'm going to take the other one as well. You can see sometimes it's quite hard to bring them into where you want them to go. Like that. Wolf, can you just explain this notch here that we've got?
Yeah, so that's the timing notch. So in case you need to angle an abutment, you take the abutment to a certain turn, and that notch will then is the indicator of that in case we want to use the angled abutment.
Okay, so you've seen I've sort of want to place them initially where I want to have them. Of course, it will not be 100% correct because of the CBCT scan, but we're just going to double check this with our ICP model. So if I go Alt B for cross section, I can then sort of make out where the nerve is. The nerve is here, and we can provisionally place it in a different location according to the mandible, okay, the bone structure. Of course, we're then going to verify whether that position is good or not. So here again, Alt B, cross section, like that. We've got a little bit of a tooth there, which has been extracted, I've been told. Okay, so that's about it. And we will just double check this now. Okay, can you see my screen, Wolf?
Yeah, so if you were to want to maintain parallel, you would have selected both implants and rotate both implants at the same time, correct?
Correct, yes.
Yeah. Instead
Okay,
of what
so,
each one separate, which you've now done, but you would then select both of them.
yeah, that's correct. So here we've got a view of what is going on. We can grab like a little crosshair to see, and then we can fine tune this position with these buttons over here. So if I click on, it's a bit difficult with one screen. So if I click on this one here, we can move. Okay, so here we're actually looking at the molar. So okay, here. So let's just, you can see how I think it moves by 0.1 millimeter every time I move it, so we can adjust it or whatever. So if I wanted to move the other implant, I would select that implant and then do exactly the same thing. So we can fine tune it over here. So up or down or left or right. So I'm not going to focus too much on the placement because I'm not a surgeon as well.
Can you unhide the
yeah,
nerve, Michael? Is it possible? Or
here,
yeah,
yeah. There's a nerve. Okay.
Yeah.
Okay. and then we can rotate all the way around as well by using the slicer panner. We can move this, and we can verify the position, etc., etc. So this part is actually a very small part, because we're doing quite a lot of the alignment. The initial alignment is done in Blender, and then we just double check to see if everything is correct in the other one. Okay, so I'm going to now start making the guide. So if there's any questions, I'll just have a bit of water.
Can you just maybe color code some of the models now, Michael?
Yep. Okay. So we finish with this menu altogether. I'm going to go to the next menu here. We'll just take this color, make it a color. Like that.
And
you see properly well?
Yeah, that's all right.
Yeah. Actually, this implant, we could have moved a little bit more towards the premolar, so I didn't pay too much attention with that, but yeah, so a bit of fine tuning here and there.
Just a little bit of question. When you import the implant from the component module, it was quite hard to just move them to the model itself for the destination model. And can we imagine that you just put them, for example, for where the cursor is? It will be easier for us to, just click on the cursor, you put it in under the... To
move. Yeah. You've got a good point there, Baptiste. I think, and that is possible. That is possible. I mean, if I bring in an implant and I've got it over there, yeah, you've got a very good point. I can just go shift right click and then shift S and then selection to cursor, like that. Yeah, 100% correct. Yeah, that makes your life easier. Absolutely. All right, so
Michael, just one question. If you wanted to revert back to, say, for instance, choosing just 2 molars because the situation is a little bit compact, yeah, would you just then sort of delete them all and go back, or would you just bring in from the wax module? Could you do 2 scenarios at this point or not?
Yeah, look, I would say, okay, just delete it, bring in 2 different teeth, like, and then bring in 2 other teeth from the wax up, and then just verify that the implants are in the correct position, because you want the, cylinders to come out of the occlusal surface.
Yes.
And then, of course, you'd shift them a little bit here and there. Yeah. So just go back and put some other ones in there.
And likewise, if you wanted to interchange components, like Michael's taken those implants, you could easily swap those as well. You then import a different implant and you'd interchange it.
Yeah, you then the way to do that is you're going to go back to the components module, choose a different one. And then, so we've covered that in the video, and then you just select that, and then you use this button over here where it says in the diagram planning here. So first you accept your implant, and then you select the other one that you want to replace, and then you just click replace with yours. And then that will snap the new one into the position of the other one.
Thank you.
So, if you change your mind, I think this is a 9mm, and so say you want an 8 or 11mm, you just change it. Okay, so here we're going to create sleeves. Now, the first thing we want to do is we want to delete these zones. Okay, so these are the red zones over here. These are the protective zones. I should have spoken about those. They've been offset. There is a way of making them, the zones bigger, the safety zone. but in this case, we've got a standard set. So we're going to delete the zones and start. Now, here, if you're using like Stecco inserts or you're using Medentika insert, I'll actually use one Medentika insert just to demonstrate how this works. Now, you'd have to key in your diameter. So I don't know what your diameter is. So as you click on this one, the other one flips down. So don't worry about that. Here, you're going to put in your diameter. So it could be whatever. So some guided ones are 5.5 or whatever. So you're going to have to know how big you want this hole to be, basically.
The drill bit.
And then, yeah, your drill bit or your guided shank. Yeah. And then we're going to move this up. And this works in increments of 0.5 up or down. So a lot of them are around about 9 millimeters.
So
I'll just leave.
When you first start and you saw that sleeve dip into the model, what it does, it actually aligns the top of the sleeve with the top of the implant, and then you set that incrementally on those arrows, or you can plug in your own value.
That's correct. So here you can move the sleeve to the top of the implant. This has been added because some people have a standard drill length of X amount, and they want to put the sleeve to that, the top of it. So sleeve to top or sleeve to bottom. So, but if you click on this one, the sleeve goes to the bottom, you key in your diameter, and then you're going to put your offset incrementally, or you're going to put 9 millimeters or whatever it may be. Okay, then we get to scale this, SZ, we can make it bigger.
So the reason why we scale it is because the metal insert goes in there if you're using those, and you want to have a sufficient wall thickness of at least 1 millimeter. So you'd think, okay, how big is the diameter of the metal insert? Then just add 1 or a bit more millimeters to get, you can see on the slide, the value, it'll tell you how the diameter of that actual blue sleeve is.
It's empirically important so that you've got enough material. I have seen some users that make it so very thin, it's not printable. So just think about
so
the
here
material.
we're setting the diameter, but also the length, because if the Stecco or Medentika metal guide is X amount of long, you want to at least cover that to the bottom of the actual sleeve.
Usually the insert cutters are 6 millimeter in length. So this can be between 5 and 6 millimeter or short of 6 millimeters in length. Also, another thing to note is that if you've got a lateral incisor or something, it doesn't have to be round. You can go SY and make it like this, you know, to fit into the gap of the teeth, you know, so there's no reason why it should be round. This is, you know, although you want the guide, the actual, the drill stopper to go on where it should be, but it will anyway, because we're cutting away with a guide cutter later on.
Yeah, and at this stage, if the blue sleeve dips into the model, it doesn't matter, because we'll cut that out in the end. The fitting surface will take care of that.
Exactly. So we've got the auto finish, which takes the default values of these 3 buttons. So I don't know if I should, shall we explain that? Or
I think so. I think so, Michael. That's quite an important step.
Yeah. So if your drills are too tight, for example, or too loose or something,
yeah,
you're going to click on Edit Drill Clearance. The blue is like a spacer. It's a clearance of 0.1. Now, 0.1 means 0.1 on this side and 0.1 on that side, 0.2. So there's a wiggle of 0. If you put this drill this way, there will be 0.2 over here. Some people haven't understood how that works.
But keep in mind, like 0.1 in the digital world, it looks massive. It is actually minute. And what you want to not have the drill to have such a friction that it can't spin freely. So yeah, so this is why we have the clearance here.
Now the auto one would take 0.1. So here we're going to apply it, and then we're going to make a hole. So it's made a hole going through there. Okay. Now for this one, I'm going to use an insert. Now, if we use an insert, we're making a hole first, and then we're making another hole. So there's no purpose of making this a big hole and then coming with your insert, and the insert is smaller than the initial hole. So keep this hole small. So we're going to do this. We're going to put our offset of whatever it may be. I'll just put 9 millimeters. And I'm going to now click auto, and it'll make a hole. It'll do exactly those 3 buttons. Now we're going to go to the components module, and we're going to look for the Medentika insert. We've got a lot of sticker inserts as well. Okay, so let's just find this. Medentika inserts here. So let's take I don't know, we'll just pick a random one. I hope this one's not too wide. Okay, so that's in the center of Blender. That's quite far away. So please don't use these select and match. It won't work. This is meant for our scan bodies. Go to the guide one, and where it says metal insert, we've got the same one, looks the same, but it works different. So this is specifically designed for these metal inserts. We're going to select the sleeve, and that's our destination. And then what we're going to do is we're going to select this one, match position to destination, and that flicks it straight in where we want it to be. So this one looks quite big, but yeah, that looks massive. This one's obviously not meant for this implant, maybe, because now if we use that, then we won't have enough material there to print our sleeve. So that's not the one that I'm going to be using. Let's just delete that one for now.
Yeah, so these are specially designed cutting tools that make the hole for the sleeve.
Let's go to the sticker ones, and we're going to just use, I don't know, I'll just randomly select any one, MIS or something, whatever. I'll just choose one like that. This one's actually quite small now. Oh well, it'll serve the purpose. Again, the guide module, metal insert, this is our destination, and match position to destination. Okay, here we go. And then what we do is you can see the wall thickness is not thick enough. We will not print 0.1 millimeter. It's like a fingernail. So we need to be consciously aware that we need a bit of material here. And I'm going to just S to scale, and SZ to make it a bit smaller. And then we're going to click insert clearance. Now this works even if you got 8 or 10, doesn't matter how many you've inserted one after the other. It'll take the intersection, the script, and then it will select all of those. So we're going to select that. That'll offset it by 0.1 millimeter. So if it's too tight, this is what you're going to change. Or if it's too loose, and we're going to make the hole through that. Now that changes color, so we know we're working with a different type of the sleeve. Okay, and it's transparent like that. Good. So we're going to go to the next chapter now.
So you can hide the cutting tool now, Michael.
Yeah, this cutting tool, we don't need it. So what I'll do is I've always got a hidden folder where I just chuck things into the hidden folder, and then if I can find it now.
Up.
Here. Okay. So, okay, we're going to go to the block art. Here, block art. This is we name the model. We create an offset. Now this offset is quite necessary. Wolf, can you just explain that, please, with the offset?
Yeah, so with CAD, we need to create a small clearance. We call it engineering fit. So, for example, an engineer won't have a nut and a bolt having it surface to surface. It just won't screw on. So similarly, we will always set an offset, and that space can be minute. So if you find that your guide is just too tight, well, then just change it, make the offset a little bit bigger. But the purpose of this blockout process is now to create a passive model. It can have no undercuts because we don't want to struggle when it's the patient's in the chair to actually fit this guide. It's just going to slip on absolutely passively.
So we're going to apply this, and this will give us a chance to remesh this one. We're going to go straight to block out lower, and we're going to survey. Now, in particular interest is this portion over here, and I'm looking at the undercut, the lingual undercut over here. Now, if we can reduce the lingual undercut, if we leave it like that, everything underneath it will be air, if you think about it. So we won't get a connection of the guide to the tooth if there's just a void. So this is why we're going to move this into a bit of a different position. Now I'm looking at this portion. I'm looking at my molar. Don't be perturbed with these over here. We are actually rotating the model.
It's a duplicate model, yeah. So it's not actually changing the dimensions, the coordinates in the 3D space. It's just an interim procedure to do the blockout.
Yeah, but we are rotating the model, and then it flicks it back to the original position. So that's important to understand as well. We're not playing with the view, and sometimes it can be a bit tricky to differentiate between moving the view and moving the object, but you need to go into one of these wedges to rotate it with your left mouse finger on the button. Okay, that's awesome. I'm going to leave it like that, and we're going to then create a passive model. So click on that. And you'll see it snap back into its original position. Okay, you may have missed it, I don't know, and we're going to voxel remesh that one. This is our passive model, and we're going to be working on this one. It's color coded in pink. Okay, we're going to go to the guide module, and we're going to go tubes. I will cover the paint on layer as well with this one as well. So we're going to name this. We're first going to name this model, name a target model, and then what we're going to do is shift right click to place our cursor. That's the starting point of everything, and then draw. We're going to take this dropper and drop it on the model, on the target model, which means it actually shrink wraps this tube to the surface of the model, but it has been offset, and the frame offset is 2.5. So if you are laser sintering this, you will make it thinner. And to make it thinner, in transparent mode, I'll show you A to select all. Control A will make this thicker or thinner. Okay, so this is quite important to know as well. So if you're printing in plastic, of course, it's going to be thicker. And of this offset here can be changed. So as I'm moving it, it moves into my model. If I move it out, it moves out of the model. So preferentially, we want it only just to touch, because when we cut out the fitting surface, we don't want to lose the strength of this tube. Okay, so here what I'll do is I'll extend that all the way across. Of course, you don't need to maybe go that far, but I wanted to show you with the paint on as well how that works. So here, it is important to intersect these sleeves because we want to print them, and we need a connection to those sleeves. Okay, something like that. I may come across, so I'll just grab a vertex here, come across like that, choose one over there. That's looking good. So I'm going to then remesh this tube. Okay, at the moment we don't have a tube. It looks like a tube, but we've only got vertices that's been expanded into something that looks like a tube. Let's just make the offset a bit closer to the model like that. Okay, and this button is a transparent button. Remesh it. Okay, like that. And then we're going to accept it. You can put this on 0.3 just to make it a bit finer. Now, if I wanted to paint a surface, which I want to show you, select the model, which is called target model. You can see over here. Click on paint layer. Okay, and then we can paint a layer if we want to. So here, what I'll just do is just add a bit of a layer here, just to demonstrate how this pans out, how this works. Okay, so then what we're going to do is we're going to accept this layer, and I'm going to finish this layer. Then by selecting this one and that one, and then joining the two, so find yourself a join objects, or Wolfgang, like you said, right click and join. I forgot that even existed. Then we're going to remesh this one. So in the tube one, remesh it, which makes this into one object. So we can put layer, tube, layer, one on top of the other. We can design whatever we want to design. Okay, so we've got a funky structure here. All right, so there's basically just one step left, and that's to cut the inside surfaces. Okay, I should have actually overlapped a bit.
Yeah, I was thinking the same, because you want to demonstrate the way the cutting tool works, that it can clear way for the drill.
Yeah, so what I'll do is I'll just paint a section over there on purpose.
Just cover it, yeah.
Just on purpose. So paint layer. Okay, so we'll just actually purposefully bring that down into there, something like that. Okay, accept, finish, select this one, join them, remesh them. Okay, so remesh, so 0.3, accept. Okay, yeah, this is good. All right, we go to finishing. Now in the finishing, we've got guide cutters and we've got hole cutters. Now the guide cutters, we're going to select them and we can expand it. So S to scale, make yourself enough room for your surgery. Here, we don't really need to expand much. We can nick off that little bit over there if we want to. Then I'll just hide the guide cutters and expose the hole cutters. Now this hole cutter was very small because that's the initial one that we were working on. So S to scale, I will scale this beyond something like that. Okay.
So the interaction between the cut here is only the green guide, and that's it, and the cutting tool. So don't worry about it. It's not going to cut anything else but the actual green guide.
That's right. So what I'm going to do is I'm going to choose my tube, and we're going to now go select objects and use all guide cutters. Click on that one, and that will then take these guide cutters, and it should then make cut it as it has over here now. Okay, there, and it's nipped off that on the left hand side. So with it being selected, select object and use all hole cutters and click on that, and that should make the holes going through this. Okay, which it has perfectly. Okay, now we want to still cut the inside surface. At the moment, if I go into cross section using Alt B, we've got this happening over here. Now, in order to cut the inside surface, have it selected and select objects and cut fitting surface. And that should then cut this out, which it has. Okay. And then finally, we've got these here, which also cut into the model. No, they don't. Yeah, maybe a little bit here and maybe a little bit over here. Select both of these, select object and cut fitting surface. Okay, so let's have a look. Yep, it's nicked out this little piece and it's nicked out maybe a little bit over here. Okay, now that concludes it. You don't have to join these. Well, can you just explain with the joining that, you know, with the resin printing?
Yeah, because
like unifying, I mean.
Yeah, that's not really necessary with the acrylic resin printers. It is necessary though for metal sintering because you need one mesh that is just completely unified. But for the acrylic resin printers, it's not necessarily. The slicing program will create the layers of the light, of the UV light as it is. So you would just select those parts and then export them.
Good. Select 1, 2, 3, file, export, STL. Just click selection only, put whatever you want and export it. And that finishes it.
Michael, can you make a hole in the model as well in case the lab wants to print it?
Oh yeah, into the actual hole. There's one other thing is you can export the data as well. So by exporting the data, you're going to get a CSV file with all of the components that you have used in this specific. Here you'll see metal inserts, and this is a component number. The component numbers are all filtered out, and then they will appear in a CSV file in your Blender where you've saved your file. So I don't know if I should do this now. I think I'll just leave that for now. We've covered this extensively in our tutorials, but if you wanted to still cut a hole in the model, we're going to click on this one, cut hole and model, and then we will then see a hole in the original model, which is, I don't know where it is at the moment. I've got to have to look for this now. I don't know if it was called upper or here, original model here, lower. No, it hasn't cut it. I don't know.
Did it cut it in the target model, Michael?
No, I don't think it's. I shouldn't have hidden it. That's a problem. It was hidden away, I think. Okay, try again. I don't know. Let's try again. It's thinking. Yeah. No, it hasn't done it. Oh, well. Okay, we'll just have to leave that for now. I'll have to check into it. Okay, so that's completes it. I'll just stop sharing my screen.
Excellent.